12.2, more limits. So this is really just a continuation of what we started with in 12.1. Okay, but the catch is now, as we're looking at number 1, the limit as x goes to -3 of this function. Well, you should be able to quickly look at the denominator and see that this function is not defined when x is -3. So just simply plugging in -3 everywhere you see an x is not acceptable. So we need a plan B. Well, plan B, factor. Do not lose the limit as x goes to -3. It's still part of the problem. We have not evaluated that yet. Okay, but the x squared plus x minus 6 will factor as x plus 3 times x minus 2, all still divisible by x plus 3. Now, hopefully at this point, you recognize the x plus 3's will cancel. I still have the limit as x goes to -3, but now our function is just x minus 2. Now, everywhere I have an x, I can plug in -3. Now, when you do this, do not write the limit as x goes to -3 anymore. Very, very particular about that. If you have not put that in yet, the limit as x goes to -3 needs to still be there. But the second you plug that value in, don't be writing limit as x goes to -3 anymore. Does not belong. So for this problem, what is the limit as x goes to -3 of this function? The answer is -5. So that would basically be our first, I guess, idea, something to look for, factoring. Okay, next one. Find the limit as x goes to 1. Well, you look at this, x cubed is 1, x squared is 1, x is 1, but so we end up with 1 minus 1 plus 1 minus 1 in the denominator. And so we get 0 in the denominator. You actually get 0 in the numerator as well. Bottom line, there's an issue. We cannot just plug in 1 for x. All right, so again, we're going to factor. 4 terms in the denominator, just do grouping. I would just keep it simple and group the first 2 and group the last 2. So we still have the limit as x goes to 1. X cubed minus x squared, factor out an x squared. The x minus 1, it's basically an understood 1. Let's go ahead and write it for teaching purposes. Now we have a GCF of x minus 1 that gets factored out times what's left over, which is the x squared plus 1. Now, hopefully at this point, you see that the x minus 1's cancel. I am still writing the limit as x goes to 1, but now all I've got is an x squared plus 1 in the denominator. Understood 1 in the numerator. Now I can plug in 1 everywhere there is an x, so I do not write limit anymore. It's simply going to be 1 over 1 squared plus 1. So our final answer to this problem is just simply 1/2. And then we get to number 3. Now, number 3, again, I cannot just plug in 0, but factoring is definitely not going to work either. So what can we do with this? Well, in this case, the trick is to notice that the numerator is a binomial, and there's also radicals involved. And so what we are going to do is multiply by the conjugate. Now, you're used to doing that when the radical and the binomial were in the denominator, not the numerator. Okay, remember at this point, we're not worried about fixing the radical. We're worried about trying to figure out how to evaluate the limit. We simply cannot evaluate the limit the way it's written. So we've got to manipulate it. So we're going to multiply by the conjugate, which is the same two terms, but you change the sign in the middle. So it's going to be the square root of x plus 1 plus 1. Now that's only legal if what you do to the numerator, you also do to the denominator. Now, if you remember, on top, the numerator, any binomial times its conjugate will always be a difference of two squares. So we're going to get the square root of x plus 1 squared minus the 1 squared. Now, I don't normally do this step, but since I'm talking to an empty classroom at the moment, we're going to do that just to show it. On bottom, do not distribute. It's just simply x times the square root of x plus 1 all in parentheses. Now, I do need to clean up my numerator, though. Now, when we do this, the square root and the square cancel, so it's just going to be an x plus 1 minus 1 squared is still just 1. And I know this is tedious, but I am very particular about this. Right now, can we cancel the x on top with the x on bottom? Well, that x and that x cancel. And the answer is no, because there are plus signs involved. So it is not legal to cancel those x's yet. But the plus 1 and the minus 1 do cancel as we're cleaning this up. So I have the limit as x goes to 0. The plus 1 and the minus 1 cancel, leaving just x on top. And now that there are no longer any plus or minus signs, now those x's do cancel. But you have to do them in 2 steps. So we're left with just that, which generally is unacceptable. You know you cannot have radicals in the denominator. Not worried about that at the moment. I'm still trying to evaluate the limit. But now I can. So everywhere I have an x, plug in 0. So square root of 0 plus 1 plus 1. We evaluate this. We're going to get, again, an answer of 1/2. Now, it's just a coincidence that the last 2 problems got the same answer. Now, at this point, just for argument's sake, let's say, what if I ended up with this as my answer? Then, yes, I need to fix it. Don't leave that as your final answer. Multiply both top and bottom by square root of 2 to fix it. Okay, but in this case, we just got an answer of 1/2. We are done. All right, next, one-sided limits. We kind of talked about this in the previous lesson. I just didn't really say what I was doing. Your one-sided limits simply means limits from one side, not both sides. Limits from the left. Now, got to be clear about this also. I need some space. Let's go back up here. Give me a little on our number line. Let's just call that C. Now, your typical number line, actually, if that was 0, these would be your positive numbers. These would be your negative numbers. Agreed? Well, with that in mind, still imagine that, but just whatever the value is, C, if we are coming from the left going this direction, but from the left, we're going to use a minus. That would be our little designation. If we are coming from the right, then there's going to be a plus, and it's a little superscript. So that's what that is right there. So if you see that little minus or the plus as a superscript as your limit as x goes to c, that just simply means a one-handed limit. The minus means coming from the left. The plus means coming from the right. So as we move on to number 4, scroll it a little too far. Find the left and right hand limits as x goes to 0 for this function. All right, previous lesson we talked about f of x equals. This right here would be a new graph that you need to learn. Quick sketch quiz. Well, this graph up here, there's an extra 2 involved. What does that 2 do to the graph? Well, it's just going to make it be twice as far as normal. So in other words, whereas the original graph was at 1, this graph is going to be at 2. And the original graph was at -1, it's going to be at -2. But that's the graph of our function that we're looking at. So with that in mind, find the left and right hand limits. So the limit as x goes to 0 with a superscript of a minus of our function. You have to put the function there. There's no such, kind of like there's no such thing as sine without an angle. There's no such thing as limit without a function. So that simply is saying the left-hand limit. So coming from the left, so I'm coming this way, what y value are we approaching? And the answer is a y value of -2. So there is a left-hand limit. Limit as x goes to 0 from the right of our function. So what is the right-hand limit? So coming from the right, as x gets closer and closer to 0, we are approaching a y value of +2. So there is a left-hand limit, -2. There is a right-hand limit, +2. Now, just to make sure that there is no confusion, what we did in the previous lesson, 12.1 though, was the limit as x goes to 0, period. Now, since the left-hand limit was -2 and the right-hand limit was +2, and those are not the same, that's why in the previous lesson the answer was does not exist. So the limit itself does not exist, but the left and right-hand limits do. And I think I jumped the gun a little bit because I think that's what this next box is. As we flip the page. If f is a function and c and l are real numbers, then the limit as x goes to c of f of x equals l. If and only if, that's what IFF stands for, if and only if both the left and right hand limits exist and are equal to L. So yes, that's what we just said. All right. Again, lots of calculus concepts here with this. But again, this is basically a calculus lesson. This is what we will begin with next year. Find the limit of f of x as x approaches 1. And we're looking at a piecewise function. And do notice, it's this way on purpose. As x approaches 1, 1 is where it switches from one function to the other. 4 minus x, that's a line. Y equals 4 minus x, that's a line. Continuous everywhere. Y equals 4x minus x squared, that's a parabola. Continuous everywhere. Okay, but the question is, and I'm just making something up. Okay, we've got a line and a parabola. The question is, do they meet? In this case, they don't, or they do, kind of thing. And actually, I did those exactly backwards because the line's actually going down and the parabola is opening down. But the point is that we're just we don't know what's happening at 1. That's what we need to find out. So the way we do this, though, is we look at the individual pieces. What is the limit as x goes to 1 from the left for this function? And what is the function when we come from the left? Coming from the left would be the linear part, 4 minus x. Now at this point, now the linear part is in fact continuous, so I can just plug in the 1. And when I plug it in, I don't write limit anymore. So my left-hand limit is simply 3. All right, now let's do the right-hand limit. So the limit as x goes to 1 plus, so coming from the right, of the actual function. Now, when I come from the right, what piece of the function are we looking at? The quadratic part. And again, now, everywhere I have an x, I can plug in the 1. And in this case, I also get an answer of 3. So, because the left-hand limit and the right-hand limit both are the same, then I can say the limit as x goes to 1 of my function is in fact 3, because the left and right hand limits agreed. All right, number 6, more piecewise. Show that the limit of f of x as x goes to 2 does not exist. Okay, show. So I've already told us the answer. The answer is it does not exist. So the real answer to this problem is the work that proves it. All right, so the limit of f of x as x goes to 2. Well, once again then, what we need to do is left and right hand limits. So what is the limit as x goes to 2 from the left of our function? All right, well, where would I be if I'm approaching an x value of 2 from the left? That would be this part right there. So it would be the limit as x goes to 2 from the left, and my function is simply 10. Now, everywhere I have an x, plug in 2. There's not any x's. The answer is just simply 10. All right, now let's do the right-hand limit. So what is the limit as x goes to 2 from the right of our function? Well, as I'm getting closer and closer to 2 from the right, I'm coming from this piece. So it's going to be the limit as x goes to 2 from the right, and the part of the function I'm using is just the constant 12. So again, now, everywhere I have an x, plug in 2. The answer is just 12. Now, they don't match. We want to say that. So the limit as x goes to 2 from the left of our function does not equal the limit as x goes to 2 from the right of our function. Therefore, 3 dots in a triangle is therefore the limit as x goes to 2 of f of x does not exist. And that was our proof. But the proof is showing that the left and right hand limits do not match. All right. And last one. This one's kind of an interesting one. This is one of those problems that you usually struggle with at first, and then for some reason, all of a sudden the light bulb goes on, and when the light bulb goes on, it is incredibly easy. It's just a matter of when that light bulb goes on, and the sooner the better, because this is a huge, huge calculus concept. Given some function, doesn't matter what it is, some function, find the limit as h goes to 0 of f of x plus h minus f of x all divided by h. All right. So I'm looking for the limit as h goes to 0 of f of x plus h minus f of x all over h. So that the limit as h goes to 0. Okay, we're not doing left and right hand limits. We're just going to evaluate this. All right, but the first question is, what is f of x plus h? And here's where I have to go back and be silly because I pretty much never have anybody tell me the right answer the first time. So I'll pause for a moment. What is f of 2? Well, if you look at your function up here for f of 2 would be 2 squared minus 1. I don't want the actual answer. That's what I'm looking for. It's just 2 squared minus 1. What is f of 7? 7 squared minus 1. What is f of star? Star squared minus 1. So what is f of x plus h? X plus h squared minus 1. I do not know why, but if I just ask you this question, you can't tell me. If we go through this process, you can. So when you get to this problem in your homework and on test, do this process so that you can figure it out. All right, so back to our problem. What is f of x plus h? Go to our equation. Everywhere I have an x, plug it in x plus h. So I'm going to have x plus h squared minus 1. I'll go ahead and put that in brackets. Minus. Okay, but I still have an f of x. Well, what is f of x? Oh, that was easy. It was just simply x squared minus 1. All being divided by h. Now we need to clean all this up. Limit as, oops, I started saying x. It's not x, it's h. The limit as h goes to 0. X plus h, quantity squared. Well, that's a binomial squared, expands as a perfect square trinomial. So x squared plus 2xh plus h squared. Don't forget the minus 1. And then now for the second term, there's a minus that gets distributed. So it becomes minus x squared plus 1. All being divided by h. Looking pretty messy. But x squared minus x squared, cancel. Plus 1 minus 1, cancels. So it's not quite as bad as it originally looked. So limit as h goes to 0 of 2xh plus h squared all over h. Now, in this case, I would now recognize that everything, I do have a plus sign involved, but everything has an h. So it's all divisible by h. So when I divide everything by h, then I'm left with just simply 2x plus h all over 1, but I'm not going to write the over 1. And now that that h on bottom is gone, now I can plug in 0 for h. So I don't need to keep writing the limit anymore. Now we have a continuous function, plug in 0 for h, and so I get 2x plus 0. Our final answer here is 2x. All right, this is a limit with what's called the difference quotient. So again, this part right here, huge concept for calculus. So I would make sure that we know it and know it well. Be very confident in it. And that wraps up 12.2.